Okay, we're going to finish up section 4.1 with a couple of definitions. You've dealt with these before with other graphs, even functions and odd functions. Even functions, the definition, a function for which f of negative x is equal to f of x for all x in the domain of f. So a couple things about even functions. A graph of an even function will always be symmetric about the y-axis. An even function is a function for which replacing x with negative x leaves the expression that defines the function unchanged. So if you can replace the x in the function with negative x and the function does not change, the value of the function does not change, that's an even function. So algebraically, you could test it just by replacing the x with negative x to see if, and then simplify it to see if the function has changed. Graphically, if a function is even, then every time the point xy is on the graph, the point negative xy is on the graph. So that's kind of what creates the symmetry about the y-axis. So let me give you an example. So example of an even function in these trig functions would be cosine. So the cosine is an even function. So let's just think for a second, looking at the graph of cosine. So now that we know what the cosine graph looks like. So we know it starts at 1, and then at pi halves it's at 0, pi it's at -1, back to 0, back to 1. So if I continue it on the negative side, at negative pi halves 0, at pi -1, and back and so on. So you need good enough to get the picture here. All right, so you'll see with cosines, it's the graph of y equals cosine x. Notice I didn't draw it's not a very neat picture here, but you can see the symmetry about the y-axis. You can see that when xy is on the graph, negative xy is on the graph. And so it satisfies the definition of an even function. All right, an odd function, just like it is with all other graphs, a function for which f of negative x is equal to the opposite of f of x for all x in the domain of f. The graph of an odd function is symmetric about the origin. An odd function is a function for which replacing x with negative x changes the sign of the expression that defines the function. So when you evaluate f of x and f of negative x, you get opposite signs. So that's how you can test algebraically. If you can replace x with negative x and it causes a function to change sign, then it's an odd function. All right, and if a function is odd, then every time xy is on the graph, so is negative x, negative y. Okay, so let me give you an example of that one. So this would be sine. Sine would be an example of an odd graph. So looking at or odd function. So looking at the graph of sine, which we know at 0 is 0, at pi halves it hits its maximum 1, back to 0, down to the minimum 0, and at 2 pi it's completed its cycle back to 0. So let me kind of sketch the graph here. If I continue it on the negative side, it's going to go down to -1, back to 0, up to 1, and so on. All right, so you can see that it's not symmetric about the y-axis like the cosine is. But when xy is on the graph, negative x, negative y is on the graph. And when we have that symmetry about the origin, that's an example of an odd function. So y equals sine of x is considered an odd function. All right, so example 7 says show that secant is an even function. So we just want to kind of do a little proof-like thing here to show that secant is even. So let me show that secant of negative x, we'll start with secant of negative x, and to show that it's an even function, I would want to show that the secant of negative x is equal to the secant of x. Well, the secant of negative x, since secant is just the reciprocal of cosine, would be the same thing as 1 over the cosine of negative x. Because cosine is negative, or because cosine is even, it follows the definition of an even function that cosine of negative x would be equal to cosine of x. So I'm going to say this is the same thing as the cosine of x. And my reason here is since cosine is even. So by the definition of it being an even function, cosine of negative x and cosine of x are the same. And 1 over cosine is secant, so I can go back now to say that's the same thing as secant of x. So basically I've proven that the secant of negative x is equal to the secant of x, and that by definition makes it an even function. All right, in the final example here, says to use the even and odd function relationships to find exact values for each of the following. So this is kind of where that's going to come into, where you actually use the even and odd function idea there. Sine of negative pi thirds, since sine is an odd function, the sine of the negative x, remember, is equal to the opposite or the negative of the sine of positive x. So because sine is an odd function, the negative sine of pi thirds, the sine of negative pi thirds is equal to negative sine of pi thirds. So straight from the definition of an odd function. And then I can go to my, to actually find the value of sine of pi thirds, which is square root of 3 over 2. So it's negative square root of 3 over 2. Secant of negative 150. Now secant, because it's an even function, the secant of negative x is equal to the secant of positive x. So this should be the same as the secant of 150 degrees. Okay, and that's because it's an even function. So by definition, the secant of negative 150 and the secant of positive 150 are the same thing. So then I just need to evaluate the secant of 150. So I think of same thing as the cosine of 150, the reciprocal of the cosine of 150. So if I think of the cosine of the reference angle 30, so the cosine of 30 is square root of 3 over 2. But I don't want the cosine, I want the secant, so I've got to take the reciprocal, so it's 1 over square root of 3 over 2, which I can simplify to be 2 over square root of 3, and I know that web of sign allows you to leave it that way, but I'm going to go ahead and rationalize it. And then I also have to take consideration, this is in quadrant 2, and in quadrant 2 cosine is negative, and therefore the sine will be negative. The secant will be negative, I'm sorry. So negative 2 square root of 3 over 3 would be my secant of negative 150.